My name's Alex Bennett, and here's the JLS Product Inventor Test 2. Here's my cutter sealer design. I did it in Adobe Fusion the best I could. I'd never used it up until now, but here's what I got in the time I had. This cutter sealer design is a folding or hinge type, as was stated in the instructions. This design, of course, includes a top half, bottom half, a hinge pin, the metal blade ring right here that's rotating, and then the ingredient cutter ring. Both the top and bottom half could be like injection molded to be a solid hunk of plastic, or shelled out as I have here. But I didn't know which one to go with, so I did either. I included in my design the domed surface that I'll show later on, that supports both the top and bottom half of the bread slices during operation, which will prevent puncturing through that bread slice. That would lead to leaks. So this will prevent leaks with this design that I had not seen in the folding or hinge designs on the market, at least the leading models. For the crimping pattern, I basically mimicked as best I could the like market leading folding cutter sealer design, but this is what I could just do by eye. Of course, it'll be different in real life, in a real prototype. From here on out, I'll just read my responses to the questions and prompts that were given about the cutter sealer. For the filling tear problem, competitor reviews consistently show that if too many fillings are put in the sandwich, the top bread slice tears and fillings leak out. I think a possible solution to this is to include in the new cutter sealer design a top and bottom surface to support the top and bottom slices of bread during operation, as I showed here. This domed piece and this domed piece. The typical hinged folding cutter sealer design type has two large open holes on both the top and bottom halves, which support neither the top nor the bottom surfaces of either bread slice. I think including a top and bottom surface to the design, such as the top surface in the plastic multi-piece cutter sealer, which I termed like this. This design type includes those the top surface, and then the bottom surface would be the counter. I think including that top and bottom surface would mitigate this issue. It would theoretically limit the volume of the internal ingredients permitted in the finished sandwich, but it would prevent the internal burst pressure from the ingredients from rupturing the top or bottom slices of bread during operation. I've included in my design both the top and bottom surface, which would both support both the top and bottom surfaces of bread, as I've stated. An optional modular cutter sealer design could even include individual top and bottom surfaces of varying depths and volumes to swap out, with some allowing for lesser internal ingredients and some allowing for more internal ingredients based on the arc and shape. So with these two domes here, that gives us a certain internal volume. But if these are detachable plates given in a modular kit, these arcs could be even deeper or higher, allowing for a larger internal volume or smaller. What shape of sandwich would I choose and why? I think for the product just entering the market, JLS's new product, a circular sandwich shape would be the bit safest at first. I would wager that the first product JLS would want sold under their brand in this market segment should be a safe and reliable tool for making homemade Uncrustables. With a circular cutter sealer design, the entire crimped sealed periphery of the finished sandwich theoretically has the same bonded strength, leading to no distinct weak points. As I've shown here, there's no there's no stress concentration relative to the other edges or periphery in this design. This contrasts with the square or squarish shaped cutter sealer designs that create 4 flat crimped sides along with 4 radius corners, which introduce 4 stress concentrations. I'd predict that most sandwich leaks and failures at the periphery would present at any of those 4 relatively sharp radiused corners, given that this is where the crimped bread joint will experience the most stress and strain. A circular uncrustable sandwich theoretically experiences a uniform stress and strain along its entire crimped periphery, leading to a more reliable and safer uncrustable sandwich. Following successful user reviews and operation of the circular cutter sealer on the market, JLS might then venture out and begin designing a square-shaped cutter sealer with the lessons learned from the initial circular cutter sealer design. As I said, my design features an overall circular shape, at least initially. What size of sandwich? One size fits all or adjustable? I think it'd be safer bet to stick close to the size of most of the successful hinged or folding cutter sealers, but perhaps increase the overall size of the finished uncrustable by maybe 20%, maybe at most. I don't think that any of the available cutter sealer designs on the market create a sandwich large enough to substantially fill up children, much less teens or adults. If I sent children off to school with the sandwiches made by the leading cutter sealers on the market, I would feel compelled to send them with at least 2 per lunch or meal. It'd be nice if there was a larger cutter sealer option on the market. However, if a cutter sealer is too large, the internal ingredient volume and mass may be too large for any weak or soggy bread to reliably and safely contain during transport when thawed or thawing. This is why I think any increase in the overall size of a new cutter sealer should not exceed about 20% of the current market-leading cutter sealers, at least for a first prototype. I also think that a size-adjustable cutter sealer design would be so complicated in design as to be either too expensive for most families to justify in this economy or too complex to operate easily and quickly, which is part of the point of the cutter sealer. Additionally, I found that in the user reviews of the plastic multi-piece cutter sealer, as I termed this one, nobody knew what the smaller variant of the cutter sealer would be useful for, let alone use it. Everyone who reviewed that design type, as far as I saw, exclusively used the larger cutter sealer variant. This leads me to believe that almost all users will use the larger variant of any size adjustable cutter sealer, so long as that variant produces sandwiches that can withstand transport when thawed or thawing. The incomplete cut problem: sandwiches sometimes are not fully severed when cut. The inclusion of a metal blade ring that severs the bread just beyond the crimping teeth could certainly reduce the frequency of incompletely severed sandwiches. This blade right here. These rings are often included in the successful folding cutter sealers on the market. However, the leading folding cutter sealer designs allow only for compression during the cutting of the bread and do not allow for translation of the ring along the horizontal plane to fully sever the bread. Think about taking a regular kitchen knife and attempting to cut a slice of bread from a loaf by solely pushing downward on the knife with the knife blade. There must be translation of the bread with respect to the horizontal plane along with the downward force to reliably, cleanly, and safely cut the bread, regardless of whether the blade is serrated. My design includes the metal blade ring as well, but the ring's blade edge is serrated, as shown here, so that even without translation of the blade serration with respect to the horizontal plane, increased pressure along each serration transfers into the bread, allowing for a more reliable and complete cut. Additionally, if the cutter sealer is of a circular design, the user could, after pressing the sandwich in the cutter sealer, grab with their fingers the serrated blade ring and rotate it about its vertical axis to introduce translation, essentially mimicking a serrated knife translating across the bread for a complete and severed cut. What crimp pattern would I choose along the perimeter and why? I think the crimp pattern should largely remain the same as the market-leading folding cutter sealers, unless significant time is devoted to prototyping new crimp patterns for the new cutter sealer design. Perhaps small variation of the dimensions of the teeth and recesses of either half of the cutter sealer could be introduced, but the overall crimp pattern is critical to the success of the cutter sealer. The current crimp patterns create successful and mostly safe and reliable uncrustable sandwiches, as we know from user reviews. I think along with the cutter sealer's size, the new cutter sealer's crimp pattern should not deviate too far from that of the most successful folding cutter sealers on the market. Following successful market introduction, revisions to the crimp pattern could be implemented following extensive prototyping and testing. This is due to the great variation between all the breads available to the average consumer. Some breads are thicker, some are thinner, some are drier, some are moister, some are tougher, some are softer, some have textures and consistencies, leading to better adhesion to itself during operation, and some do not. My design features a crimp pattern largely similar to those of the market-leading folding cutter sealers, but further prototyping and testing could change that in the future. A possibly successful crimping pattern could mimic the crimping of an aluminum soda can lid, where the bread would be folded over itself more than once, right here on this lid. However, I think that the pressing operation would involve more than one step for the user to complete, as an aluminum can's lid is sealed in at least two separate seaming operations. A crimping mechanism like this would likely also add much more complexity to the cutter sealer's design and may not substantially increase the reliability and strength of the crimped joints to be worth the investment. However, further prototyping could illuminate this concept in the future. Would you include a feature so that users can cut deli cheese or deli meat to fit perfectly inside the sandwich? Why or why not? I think including a metal ingredient cutter ring would be a great idea, as I included here. Whether most users would actually use it aside, including another component in the kit would signal to potential customers that they are receiving more bang for their buck by purchasing your cutter sealer kit with the ingredient cutter ring included. This cutter sealer kit would also be a much more versatile tool, allowing users to create uncrustable sandwiches with solid ingredients like meats and cheeses, instead of solely spreadable ingredients like peanut butter or jelly. As I mentioned in my previous questionnaire, many modern kitchens are simply too crowded to purchase or own many kitchen tools that users may wish to have, but cannot afford to store in their kitchen or cabinets due to space or storage space. Selling a versatile tool that can create much more than solely uncrustable sandwiches with spreadable ingredients would be a huge advantage on the market. Additionally, if the new design includes a metal blade ring as described above, right here, purchasing the ingredient cutter ring, this one, from the same manufacturer or vendor that supplies the blade ring may be cheaper overall than the purchasing of both rings from separate vendors. Cheaper for JLS. My design includes an ingredient cutter ring as part of the kit, shown here. What ideas do you have to make this product a banger and beyond just being functionally excellent? Something that could make JLS's new cutter sealer stand out in the crowded market is a lifetime warranty on any of the components of the kit. If the hinge pin, metal blade ring, or metal ingredient cutter ring begin to rust, JLS could replace them for free. If any of the plastic components break, not due to misuse, then JLS could replace them or send a new cutter sealer kit for free. I think relatively very few customers would initiate the warranty process, and many would likely forget about the warranty altogether by the time components may begin to fail. Potential customers would read about the lifetime warranty on the product page, but likely just skip the headache of the warranty process and purchase another kit given how affordable they are, should they have gotten a lot of use from their first cutter sealer kit. My design includes both the top and bottom supporting surfaces on either half of the cutter sealer, allowing for either bread slice to be supported during the pressing operation. This would allow users to make uncrustable sandwiches without either bread slice bursting open from overfilling the sandwich, as described above. JLS could use this to their advantage on the product page, as I have not seen any other successful folding cutter sealer designs with this design concept included. Anything else you think is particularly relevant to consider at this point? As I wrote in my previous questionnaire, given the recent widespread concern about materials and chemicals such as PFAS, BPAs, toxins, microplastics, using top-tier materials that would not leach these particulates is a huge advantage. If we assume that most users are using cutter sealers to make uncrustable sandwiches for their children, and that many contemporary parents of young children are extremely sensitive to what they feed their children, then manufacturing the new cutter sealer from premium materials and then advertising that on that product page would certainly be an advantage. My design would likely be required to be manufactured from plastic, but a different out-of-the-box design or prototype could perhaps be manufactured from stainless steel, for example. There's a massive craze recently to replace plastics with glass, ceramic, wood, or stainless steel to mitigate the transmission of these particulates into our bodies and the bodies of our children. I believe this craze will not only grow in the future as more and more people are learning of these foreign particulates, and as we learn more about their long-term health effects. All right, thank you.